what it meant, masking dilemma. When running into masking dilemma, then don't continue doing masking. If you do that one, you will go into the uprising motion. You'll find a lot of response to pivotal, but no one is on the plateau anymore until reaching the maximum output of the pivotal signal. You cannot find the first one, and you know you are in that kind of situation. So that means whenever we have masking dilemma condition, then stop doing the masking procedure. Even though we need to get it done, that means we cannot find the mask threshold anymore. That means, well, we just leave it that way. Then we probably can say based on unmasked threshold, we suspect some hearing disorder, some kind of hearing loss in this ear, and in that ear as well, due to masking dilemma. The masking procedure cannot be performed. And we can do in the field, we can do other tests. We have other outside Hilton audiometry, we have other tests to find out where the pathology is. But right now we are talking about masking dilemma. So this is a simple but kind of also needed concept as we run into it from time to time. So for masking dilemma. Now, need you to use next set of handout. I'm gonna move to the concept about to overcome the occlusion effect. When we use this concept of handout, starting from page 104 with this picture. Okay? This is, I say, the third set of handout. On to the bottom portion, here is a small paragraph talking about occlusion effect. Remember, when you are going back. Remember earlier I had you guys, when we talk about occlusion effect, I had you guys occluded your ear, right? By doing so, making R, E, O, U sound. Whenever you have the ear occluded, then due to the bone contraction, the air molecule vibrating in the cannot get it out because the ear is occluded. Then in that ear, at the moment it is occluded, the R sound, E sound will become temporarily louder. Whenever you let go of your finger, the R sound will back to its original level. So that occlusion effect means when an ear is occluded, such as whenever under the headphone is occluding the ear. Whenever we do masking AC threshold, the headphone is here. Whenever we do PC threshold, if we need to do masking bone in the ear, we need to use headphone. Put the headphone back in there to mask out the better ear, the non-mask, the non-test ear. Then this ear, the better ear, is also under the occlusion by the headphone. So whenever the ear is occluded with some kind of device or something, the threshold, the actually bone production threshold in that ear will become temporarily better. Remember that phenomenon of occlusion effect occurs only on R, E, U sound, like not on S or Sh kind of high frequency sound. Because occlusion effect occurs only at and below 1000 Hz. On an earlier handout, you'll have a table there, 1000 Hz maybe 10 dB. They become better by, the hearing threshold becomes better by 10 dB or so. At 500 Hz, I will talk about 20 dB. 250 Hz, probably about 30 dB or so, something like that. Okay. Now, why we need to talk about occlusion effect one more time here, while we are talking about masking procedure. Now, the field is very understandable. Now, headphone in here. Let's say this ear is worse ear. Like earlier, we said 50 dB. This ear was the left ear, and this is the better ear. And we have headphone on. We send the noise to here while trying to do masking. But right now, this ear, better ear, is also with headphone on, right? It's under occlusion. Then this ear threshold will be temporarily better by about 70 dB because of that occlusion effect. So how do we do to find out true threshold? Still, we use masking procedure. We find a plateau. But my way is, whenever you find plateau, you think you reach plateau, the first tone, while allowing you to further increase noise, say plus 10 plus 10 plus 5, or plus 10 plus 5 for phone. That's it. Either way, you found plateau. My way is now, if this testing is actually at the 1000 Hz or below, then I remind myself occlusion could be there. But there, the better ear is under occlusion. The threshold there at the time under earphone will be temporarily better. While we think we have this ear masked out by using the noise because we reach plateau. Yes, which is true. But right now it's at a lower frequency. That ear threshold is temporarily better. Maybe by 10 dB. So how do we handle this situation? We found plateau. And my way is we add zero noise by a little more. If the occlusion effect is becoming better in hearing, the hearing sensitivity becoming better temporarily by 10 dB, then how about we add noise by another 10 dB? If I still get the person respond to their pure tone level, then that level is actually a true threshold. So mark it down as master threshold. So to overcome the occlusion effect, the principle, I need you to understand the concept. The concept is the ear under occlusion will be with the threshold which will temporarily become better by certain dB, by certain amount. Then to overcome that one in doing masking is that we use additional more noise. If your hearing become better by 10 dB, then I use additional 10 more dB noise to verify I am still in the plateau. I have reached the plateau. I found the threshold. So that's why in the text, in this handout, the author saying, remember effective masking level simply means the noise level used. Okay? This one, treat this one in. Remember when we do masking, the initial masking level would be equal to the AC of non-passive yield to be plus 5 plus 10. The person used AC non-passive yield. So the person recommends initial masking level plus OE, occlusion effect, amount of occlusion effect. If at 1000, probably 10 dB. If at 500, probably 20. If lower frequency further, 250 Hz, probably 30. That's what it meant. So the concept is we just use a little more noise to do the masking, to find plateau. That's what the person recommends. I use slightly different, as I said. I still use my initial masking level, which is AC non-passive plus 10. I prefer to do that one. When I found plateau, I reach the threshold. Then if I take a look, if there's a lower frequency at or below 1000 Hz, I just add a little more noise. I just maybe add another 10 or another 15, another 20 to see if the person still responding. Maybe that's a good response. Maybe in the real plateau, which is in the plateau, and mark that one as threshold. The concept is to overcome that one, we need to add a few more dB of noise to overcome that. Threshold becoming temporarily better in the non-test ear. Clinically and actually, one difficulty is we have no way to know ahead of time the amount of occlusion effect. How much your threshold will become better at this frequency, at 500 Hz, 300 kHz. We don't know. We cannot check it out. Not easy. And it always has individual difference. And the difference at those three frequencies. So we just do a little bit compensation. We do a little control. We are thinking is, okay, I found plateau, then I add a little more relevant noise, just to hoping to overcome the occlusion effect in our way. That will be better than not doing anything about it. That's just so-called to deal with the occlusion effect. Next page, I put a cross there. I don't need to really study this next paragraph. They talk about more things about how to figure out a person's occlusion effect. So probably don't need it. Okay? Then next page, this is one sample. Later on, once you study everything, don't forget to come back. Just kind of look at it. You can look at the description for your practice. Then continue, turn this page. On this paragraph, on the bottom, it talks about Weber test. put the X there, cross it out. Don't need you to study this one. This test is done by tuning fork. It's done early days when we do Kyoto Audiology. Today, for many years, not just today, beginning today, for many years already, when we have this electronic device called audiometer, we no longer use tuning fork. No one doing that kind of test. It's done by tuning fork. So, unless you have curiosity, I don't need you to study this carefully. Next page is another sample for you're practicing. The last page of this one is a good table. Listening overall the concept we have so far covered. What we need to do masking, what we do masking purpose and so forth. Those kind of tables. When you have time, study them. Right? Now, my main purpose of today's meeting is here. I discovered the masking dilemma, and I made a little bit about how to overcome the occluding effect. Now we need to go into here, talking about type of hearing loss. The overall definition is here. Okay? I'm going to take a look at this one. Now, let's use this set of handout. This one will give you all the concept, type of hearing loss. Remember earlier we studied type of hearing loss. Type of hearing loss. This is based on the location of the pathology. This outer ear is my hand drawing, not very authentic, but I think good enough. You see, I think the line there along the states, footplate states. This is conductive mechanism. Remember that one? Outer ear, middle ear. This is sensory neural mechanism. Starting from there. Okay. Any pathology in the outer and or middle ear, meaning in the conductive mechanism, and have hearing loss. What is that hearing loss? Conductive hearing loss, right? Don't say you have that part forgotten. That part forgotten how to not move along. Right? If any pathology there, here or here, inducing hearing loss, that is called conductive hearing loss, because it interferes with the conduction of sound energy. Okay? Now, if a pathology in the inner ear and the nerve fiber high structure, we call that kind of hearing loss sensory neural hearing loss. That's the original definition. Because pathology in there where we have sensory and organ, those outer the cell, inner cell, basal membrane, those kind of structure, and the nerve fiber, so-called sensory neural hearing loss. That definition is based on the location of pathology, which I call an anatomic definition of type of hearing loss. That's based on the anatomic location in the anatomic structure of the pathology. That's it's a true definition. Now the question you could ask yourself is, on an audiogram, once Kyoto audiometry is done, if masking is needed at this frequency, done. If masking is needed at another frequency, conducted. Then you have all the data out on the chart, audiogram. Can we recognize the type of the hearing loss by looking at the audiogram? Okay, that's the point I'm talking about. The other way to define type of hearing loss. This one is based on the data point on the audiogram, so it's called audiometric definition of the type of hearing loss. Earlier, anatomic definition. Now, audiometric definition based on audiogram. Now, listen true. You should be able to reach very clear understanding because things in audiology is all logic. Reasonable. That's me. Now look at this one. I just used 1, 2, 3. And this part of definition is actually mentioned in chapter 2 within those pages that I mentioned to you earlier. It's not in chapter 4. They touch it in chapter 4 though. So somehow the information is scattered here and there. Now, take a look at this one. This one